we go to the next chapter, force measurement. Until now we have seen displacement, velocity and acceleration. All the three put together is called motion measurement. So now it is a new chapter on force measurement. Now this is force measurement. Now force is what is force? Force equal to m into a, where m is the mass and a is the acceleration. A is the acceleration. So that is by Newton's law of motion, force is given by mass into acceleration. So if you want to have unit for mass, then you analyze what are the units it is made up of. It is made up of mass, which you have not learned, we have not yet seen the unit for mass, whereas acceleration we know, acceleration made up of length, that is meter per second squared. So we know the standard for the standard unit for meter, and we also know this unit for the second. So now we have to see what is the unit for mass and accepted by all countries, that is 1 kilogram. 1 kilogram is the unit for mass. What is that 1 kilogram? It is in some randomly selected body, say platinum iridium cylinder kept near Paris. So that amount of mass is assumed. They might have selected some other mass also, but once it is accepted, that is 1 kilogram. Now it is always referred there as 1 kilogram mass. So 1 kilogram mass is nothing but the unit, it is a mass of the unit or the product, the cylinder which is kept there near Paris. That mass is always taken as 1 kilogram. So now it is made up of all the three units, mass, length and time. All the three units made up of the force. Now the SI unit for force is Newton, 1 Newton. What is Newton? Newton is the force required to accelerate a mass of 1 kilogram through an acceleration of 1 Newton, 1 meter per second square. So 1 Newton is equal to 1 kilogram mass through 1 meter per second squared acceleration. When it accelerates, then that force is called 1 Newton, or 1 Newton force will accelerate a mass of 1 kilogram through an acceleration of 1 meter per second squared. That is our unit Newton. But for calibration purposes, we have got the weight. What is weight? Weight is the force of attraction of a mass by the earth. That earth attraction is called weight on any mass. So that is G, mass multiplied by G instead of acceleration. Here we have got G. G is what we have taken the nominal value is 9.81 meter per second squared. That is the G value. But it is a variable one at different places in earth. This value G varies, but all countries have agreed to use this average value for all computation purposes. So whenever there is a mass on the earth, it is always acted upon by G. So we always realize a weight. So from weight of, say for example this chalk piece mass cannot be separated from its weight, because it is acted on by the weight always. Mass to separate it from weight, it is not possible. Then you have to take it into space where there is no earth attraction, then you have the mass there. So since we have the weight here and this nominal value also is there, the weight is used. Now that is unit for weight is 1 kilogram force, or 1 kilogram force, or 1 kilogram weight. That is the unit for the calibration purposes. By having the 1 kilogram weight, we can calibrate. What is it in terms of Newton? This is equal to 1 kilogram force, that is 1 kilogram mass into 9.81 meter per second squared. That is now 1 kilogram through 1 meter per second squared is 1 Newton. So here 9.81. So 1 kilogram force equal to 9.81 Newton. That is the relation between 1 kilogram force and the Newton. So now people at different places, they can go for the weight itself, 1 kilogram weight itself as standard for the force. So going for Newton, because kilogram force and Newton can be related by this relation. So kilogram weight is taken as the standard for calibration purposes, because 1 Newton, to realize it, it is you should create a force. That force is, some force is available already in nature, that is a force due to attraction of earth. So that is what we use it for all calibration purposes. Now, under this topic force measurement, we are going to see how the force or weight or different objects are weighed, and so far we have given importance to the conversion from the mechanical quantity into electrical quantity immediately, but under this one we have got some mechanical devices very often still used, they are still used. Suppose a mechanical engineer is asked to make one such mechanical device, he should know what are the different types and principles behind it. Hence, we are not going immediately to conversion of force into a voltage signal. Before we do it, we would like to see few of the mechanical devices. Under that, we have got all the mechanical devices now we have got can be brought under the title lever balances. Lever balances. Under lever balances, we have got many devices, and they can be grouped under four category: equal arm balance, and B unequal arm balance, and bent lever balance, and then compound lever balance. These are the four main types of the mechanical devices. You will see briefly what are the constructions. The common balance still used in grocery shops, very old one, still used. It is sufficient, whatever the accuracy available in this common balance is more than sufficient. So, we can weigh things see plus or minus 10 or 20 grams. Say in case of when we measure few kilogram of weight, we can have the plus or minus 10 or 20 grams weight error, that is acceptable. And in such one you will find only at the middle of the lever. This is lever, equal arm balance. From the this is the pivot. This is made up of pivot is made up of knife edge bearing. It is one of the precision bearing available and very cheap also. This is made up of some hardened steel, and the pan or the support is little bit more harder. Yeah, support should be sometimes synthetic crystals or something like that, synthetic diamond are made use of, or more hardened metal is taken. Otherwise, the knife will plow into this support. To avoid it, the pan or support is harder than the knife. So, this is the knife diameter is of the order of 10 microns. Knife diameter of 10 micron radius. That is, knife end is not a sharp end, but it is always rounded. The knife end is always rounded of the to the radius of 10 microns. So, you find the friction radius is 10 microns or is equal to 0.01 millimeter. 0.01 millimeter. Hence, you will find the friction torque in such knife edge bearing very small. Hence, we have got such accuracies. So, here we have only one knife edge bearing, and the two ends equal. This is L1, this is also L1 from the pivot. That is why it is called equal arm. And from two hooks, the pan will be hung, and the standard weight is put on one side. We all see whenever we go to shop, and our commodity is put in the other one until the pointer comes to say this is stationary mark. Until the mark stands here, we have to add the commodity, and when it is there, otherwise it will be tilting. Until it comes to the standard mark, we add weight and then we measure it like that. So, that is accuracy, say few tens of grams may be the accuracy. Whereas, we have got analytical balance, this chemical, people call it chemical balance or the physical balance, and where the accuracy can be of the order of 0.05 gram, up to that it is possible. 0.05 gram is it's possible, yeah. 0.005 gram, up to that 5 milligram, so it's possible. We have got standard weight boxes, and here we have three knife edge bearings, middle 1, end 2, 3. Three knife edge bearings are there, 2 pans, and from this point it is equal distance the other two knife edges, and CG of this lever, see it below the middle knife edge. Hence, you find any little difference, this is the commodity, any small difference, this will be oscillating. Yeah, in a scale the reference point will be the scale pointer will be oscillating. By taking for 3 oscillations readings, the correct measurement can be, this is W1 known, this is W2 unknown weight, can easily be found out by making 3 oscillations. This we have learnt in physics, that is analytical balance. To maintain the precisions, sometimes the manipulators are used to load the span or to put the weight, because if we stand near like this arm may be expanded by the body of the heat, whereas the other arm may be shorter. So in order to avoid this body heat, people stand at a distance and use manipulators to put the weight or put the standard weight and so on. Such operations are also available with analytical balance. It's a very precise measurements are made, and more precise measurement can be made by calculating the different volumes it occupy and buoyancy force of air acting on these bodies of standard weight as well as this, because standard weight will be normally occupying smaller volume and a commodity may occupy larger volume. So here buoyancy force will be more than this, that can be accounted, and to a precision of 1 part in 10 to the power of 8 also can be found out by these analytical balance methods. So for precision measurement we can go for it, but nowadays we have got electronic balance. Giving electronic balance gives up to 0.001 by 0.1 milligram accuracy. We have got electronic balances. So they were used, but in some places they may be found. This is analytical balance. And next one is unequal arm balance. Here that is one is drawn here, unequal arm balance. Now here the advantage is with a smaller weight, this is standard weight. By having a smaller weight, we can measure the higher unknown weight. That is the advantage of this standard weight. That is moved over a scale at a longer lever arm than the loading point. Then the loading, this is loading point where unknown load is connected. So by having small weight, we can measure a larger weight. But before that, we should see one more thing. Even though we compare the mass here, yeah, but in essence we are comparing 2 moments. The moment we put a mass, immediately G come into picture, attraction due to earth, and it becomes a weight. So weight W1. When weight W1 acts at a distance from a pivot, it is a W1 into L1. So W into L1 is the moment of this mass at this pivot, about this pivot. Similarly, when we put a weight, add weight, this weight W2 is obtained until W2 into L1 is equal to W1 into L1. So in essence, the process of making or measuring a weight is the process of comparing 2 moments. Even though we call mass we are measuring, but we are actually, the instrument measures 2 moments. Until the 2 moments come equal, we are adding the weight. That is when they are equal, we find the pointer stands vertical. So in all measurements we are comparing only moment here, more or less moment, because mass cannot be separated from the force, and force acts from a distance, it is a moment. So here because longer arm, the moment with a smaller weight we get this larger moment, and here larger load with a smaller moment, and we can compare, we can equalize until this is moved to and fro until the end tip of the lever stands against the reference mark after adding the weight here. Then we make a reading what is the weight, and that is how it is made. The one advantage is here in the equal arm balance, the unknown weight and the standard weight should be equal. So we should do a standard weight until the range, full range we could reach. But here by having smaller weight, we can have the larger weight, we can compare it. The problem here is we have to move this and then find the weight. So sometimes we may not be able to, we may not like to do that motion. With the moment we put the load, we want to have the reading. Such a thing is there in the bent lever balance. This is a bent lever balance. That is third type, bent lever balance. So this is the lever bent in this form, and the one end we have got this knife edge and the pan. The other end we have got a fixed weight W1 acting at a distance B from the pivot, from the knife edge. This is the knife edge. This is the knife edge supported, and above knife edge we have got as part of the lever a pointer is attached. So, the moment we put the unknown weight here, then unknown weight if you call W2, W2 into A is the moment, because essentially all these lever principles we are comparing moments W2 into A. So, it will deform until the distance B is such that W1 into B1, the W2 into A will be equal to W1 into B1. So, the distance B. Now, until the distance as it tilts, this is B is increasing, it will increase until this relation is realized. At that time wherever the pointer stands, so this may be 0 and this may be say 200 or 2 kilogram, whatever it is, 2 kilogram force until then. Even though we call 2 kilogram or 2 kilogram force, it represents force only, 2 kilogram means 2 kilogram force. So, the moment we put the unknown weight, immediately it deflects and we find the reading. A modified version of this bent lever is letter weighing machine. Still in some of the post offices this letter weighing machine is used. That bent lever, this is your bent lever. This is the bent lever is this, up to here it is bent lever. So, loading is done by having another linkage. So, this is the coupler and that is called input link, guiding link, they are called guiding link. That actually you find this here you have got 4 pin joints. So, within this you have got a 4-bar linkage mechanism, 4-bar linkage mechanism. You realize within these 4 linkages, see this is a frame which is fixed to the ground, it is a fixed link, whereas if you can call it as one of them, this is input link, this is a coupler, this you can call it output link. You find input link and output link when they are equal, you find the coupler always makes motion parallel to the fixed link. That is what is happening here. When you put letters here, it moves up and down vertically. Motions will be vertical motion only will be there, but it may shift towards, during its motion it may shift towards or away from the fixed link, and always it is parallel. That is what is made use of here as a coupler. From coupler that property is made use of. So, when you put letter, it does not tilt, it is always moving vertically up and down, that is an advantage. So, when you put weight here, it acts at the bent lever at the end of the bent lever. So, bent lever tilts, and at the other end we have got the weight W1, and as where it stands that itself is as a pointer, and it moves over the scale. So, from 0 probably it is 200 gram, up to that we can measure in these letter weighing machines. And the last type is compound lever balance. That is what it is written here, compound lever balance. That one of the design is shown here in the diagram. It is mainly made up of a long lever, it is also called platform scale. The compound lever mechanism also called platform scale. It is normally used for very large weight. Say for example, in lorry weighing machines, lorry loaded with some commodities. If the police want to measure the lorry weight, they will ask the lorry to be stopped over this platform. That is why it is called platform scale. And then they will read it, what is the weight of the lorry, whether it is permitted weight or overloaded, that they will decide. The principle is, the main advantage of this platform scale is, you can put this weight W in this platform. Actually, this is your platform. You can put this weight anywhere in this platform, the reading will not be affected. That is advantage of this platform scale. Anywhere you can put here or there, anywhere you can put, the weighting, the measurement will not be affected by the position of the weight. That is advantage that we are proving now. How the position of W does not affect the measurement. For that, say here you have platform that is mounted on another platform here. One is on the lever, this lever mounted at pivoted at O2. This main lever pivoted at O1, and the lever edges are like this, A and B. This is B lever edge, and this is A. Up to the middle, it is A. That is the knife edge there. So, if you are taking moment at O1, you can write the equation T into B. T is the tension in the, this is called tie rod, due to the weight here you will have the tension in the tie rod. So T into B is equal to Ws into A, where Ws is called the pan weight. By having different sets of pan weight and moving this is Poisson weight. Poisson weight, we can measure any, suppose a lorry stands here, then add a number of pan weight and move this Poisson weight such that this end of the lever stands against the reference mark. Then you have measured, just add this pan weight, and this reading here will give the total weight of the lorry, whatever it is that has stopped over, that has placed over the platform. That is the method of measurement. So the principle is T into B, that is T into B is equal to Ws into A, Ws into A. And now taking moment about O2, that is taking moment about O2, you can write T into C. C is the total distance that I have not marked there, total distance from this pivot to the other pivot. This is your C. This is C. That is T into C. That is it is trying to tilt the lever in this direction clockwise. The other reactions tending to rotate the lever in the anti-clockwise directions. That is two places, two forces. One is W2, we will see the W1. W1 part is W1 into F by D. That is W1 into F is this distance into whole lever. This is simply supported beam. The reaction here will be F by D, and that into E will be the moment about O2. That is from W1. From W2, W2 into height. It is simple, W2 into height. This is the motion. Now taking W, height is a common factor, height, then W1 into F by D into E by height plus W2. Now the leverage of this platform scale taken such a way that you have F by D is equal to height by E. Height by E. F by D is equal to height by E. That ratio we can easily, because we can easily select while we design. This way if it is selected, then this cancels out. This is equal to T into C is equal to height into W1 plus W2. W1 plus W2 is always W. So height into W. So we find this instrument functioning is not dependent on the W1, W2. It depends only on the total weight. Hence we say this instrumentation is insensitive for position of the load. Yeah, now we have seen, what we have seen is irrespective of the position of the load, we get the correct measurement. The measurement doesn't get affected. Now what is this magnification or multiplication factor? By for measuring a few tons of weight, we use a few kilogram only. So what is that multiplication factor? We obtain by eliminating those from those two equations. T into B is Ws into A, we derived first. That is the first lever, and the second lever we have got the O2, around O2 we have got this equation. Eliminating T, we have got W is equal to that weight what we measure is equal to A by B into C by H into Ws. So all these things we call it as R. So R into Ws. So R is our multiplication factor. So that is if you measure 110, suppose 1000 kilogram force, if multiplication factor is 100, then we can by having 10 kilogram weight here, we can measure 110, having 100 multiplication factor. That's the advantage. By having a smaller weight, we measure a very large weight. So that is pan weight. But how the Poisson weight is decided, how it is made use of? Normally pan weight is added every 10 gram, 10 or every 100 kilogram. Suppose it is 1000. Every 100 kilogram weight we have to add one pan weight, and in between say 100 to 200 we have to move these pies. That is how the measurement is made use of by using this compound balance. Between the pan weight, if the weight is there, to that extent we are supposed to move the Poisson weight. This is Poisson weight. How the Poisson weight is decided and pan weight is decided? We see an example here. Suppose the A is 78 mm, B is equal to 13 millimeter, C is equal to 80 millimeter, I is equal to 6 millimeter, W maximum 100 kilogram. That is the maximum load here. I assume it 100 kilogram we have to measure, and in this example, so r is equal to multiplication factor is 80. That means the total weight what we have to put here is 100 by 80, 1.25 kilogram, that pan weight we should have total. Suppose we want to measure here every 10, for every 10 kilogram weight, we want to put one pan weight, then that each pan weight should measure 125, that is 1.25 by 10, 10 pan weights of equal weight 125 gram. If that is the pan weight, then we should have the in between measurement, we should have a piece weight which should be little larger than this one, so that it does not move over this from its movement. So when it is 0, it will be standing here, it will be standing here. At that position, this is the counterweight. Counterweight is fixed in such a way when there is no weight here, and put this at 0 and no pan weight, only the holder will be there, and we move it until the lever stands against reference mark and fix it there, that is as 0. Now suppose we want to measure, now we have got pan weight for every 10 kilogram. Between 10 kilograms, say 1, 2, 3, 4 or 11, 12 if you want to measure, we should have the for 1 kilogram force, we should have the reading here. For that purpose, let us assume a weight of 1 kilogram force here, that is W minimum assume as 1 kilogram force. What should be the piece weight here, that we have to find out. So for that, assuming a distance of x is moved, the piece weight being WP, we move by a distance of x for the next graduations. If x is distance for that, say for 1 kilogram, let us see later. If we move like that, then additional movement is WP into x. That is being balanced, that is this side of the pivot. The other side comes from the 1 kilogram weight here. That is, we call it W minimum. So W minimum into h by c, that is tension on the tie rod will be h W, this W minimum h by t is equal to c this side, into B will give the moment about O. So that's why into B, W minimum h by c into B will be the moment the other side. We equate these two motions. Due to W minimum we have got a moment here, and the W P we have got this moment W into x, that they are being compared, and we find x is given by this equation W minimum WP h into B by c. Now for this pan weight of 125 gram, we should have a little larger weight of piece weight 200 gram, and for this W minimum 1 kilogram, and x comes about 4.9 millimeter. So every 4.9 millimeter distance we write 1, 2, 3 up to 10. So 10 kilogram means it will come here. That is how the piece weight and its graduations are finalized.